So let's get going here. So let's start with, we're talking basic matrix operations. Now I don't remember if you guys saw matrices in Algebra 2 or not. Well anyways, a matrix is is a rectangular arrangement of numbers organized into rows and columns. So, matrices are named with capital letters, and the individual numbers are called elements. So this right here is a matrix. It has bracketed sides. It's got rows. In this case, it's got 2 rows. It's got columns. In this case, it has 3 columns. There's enough space in between both so that you can distinguish between the two. Okay. It's got a capital letter for its name. In this particular case, it's matrix A. Sometimes the name, the lettering of the name, also comes with the dimensions. That's the 2 by 3. That's the dimensions of the matrix. 2 rows by 3 columns. Everything in matrices, this is important, you should write this down. Everything in matrices is rows by columns. Rows first, columns second. Each individual element has an address. Just like you have an address where you live, each element has an address where it lives. So for instance, the element of 3 lives in A11. That's A, meaning we're in matrix A, row 1, column 1. Again, everything in matrices is rows by columns. Matrices, or a matrix, I should say, matrix is the singular, matrices is the plural, can come in different sizes. It always helps to know the size before you share that information with someone else if it's not written. So in this week, when I'm talking about matrices, I will first tell you the size of the matrix. And then I will read off the matrix left to right, top to bottom, pausing after each row. So if I were to tell you what this matrix A was, I would read matrix A as, matrix A is a 2 by 3 matrix, 3, -2, 4, 1, 0, -5. Rows, left to right, pause, next row, pause, row, and so on and so forth. So that it's not just 3, -2, 4, 1, 0, 5, -5. Okay. Pause after each row, kind of like a reset. Okay. Any questions on the organization behind a matrix? Okay. We can do many things with matrices. First off, we can add and subtract them. In order to add and subtract a matrix, or add or subtract, I should say, two matrices, the dimensions have to be exactly the same. If they're not, you cannot add or subtract them. No lie. Okay. So I can only add and subtract 2 by 2 matrices with other 2 by 2 matrices. I can only add or subtract a 4 by 8 matrix with other 4 by 8 matrices. I can't add a 2 by 2 matrix to a 3 by 2 matrix because the dimensions are different. Okay? And how we add and subtract them is we take the corresponding elements and we either add those two numbers together if it's an addition problem, or we subtract those two numbers together if it's a subtraction problem. The size of the matrix does not change in addition or subtraction. Let's try one. Okay. So the first thing that you need to check is you need to check if the matrices are the exact same size. If they're not the exact same size, then you cannot add or subtract them. Dimensions of this first one, well, it has 2 rows and it has 2 columns. So it is a 2 by 2 matrix. Dimension of the second one, it also has 2 rows and 2 columns, so they are the exact same size because the dimensions are exactly the same. That being the case, then, I'm going to have my result is going to be a 2 by 2 matrix, and I'm going to take elements of the first one, and I'm going to add to them the elements of the second one. Four plus 2 is 6. 0 plus 7 is 7. Negative 6 plus negative 1 is negative 7. 2 plus negative 5 is negative 3. And then I put my brackets around it, and that is the resultant matrix after I add those two together. 2 by 2 matrix, 6, 7, negative 7, negative 3. Try that one. Oops, went too far. Now, before I begin, the very first thing that I need to check is I need to check if my dimensions work out. Dimensions of the left matrix, 2 by 2. Dimensions of the right matrix, 2 by 2. So those both work out. They're both 2 by 2s. I can add and subtract them. Okay? Another side note, if I called this first one matrix A, and I called the second one matrix B, okay, I could do this exact same problem, or in sometimes in the in the textbook, they might do this. I might do this on a worksheet or a quiz or something like that. I might give you like 5 or 6 matrices at the top of the page. And then I'm just going to say, and they're all going to have names, and then I'm just going to say, in this case, it would be A minus B. Okay? Or it could be later on when we get to multiplying matrices. It could be A times B minus A, or something along those lines. Okay? Where that way you don't have to keep rewriting matrices all the time. If you're, you know what I mean, you can have, I can make 7 problems out of just, you know, having 4 matrices all up at the top. Okay? So this is going to be a 2 by 2. And we're going to have 3 and negative 5 and 10 and negative 4. And this time now we're going to be subtracting. And then we're going to have negative 3 is our whole, negative 2 and 4. So that gives me a result here of 3 minus negative 3 is 6. Negative 5 minus 0 is negative 5. 10 minus negative 2 is 12. Negative 4 minus 4 is negative 8. So I get the 2 by 2 matrix, 6, negative 5, 12, negative 8. Questions, comments, concerns, clarifications? The textbook, along with, I've seen it in the past on finals and on some assessments as we go along, where you have a matrix addition or subtraction statement. That's what this is it's a matrix addition statement because we're adding them. And then it's asking you to find the 2 missing variables. So in this case, we would have asked to find x, and we're asked to find y. Okay? So what I would do, if it were me, to make this equation be true, I would say, well, negative 2 plus negative 3, 1 plus 6, x plus 7, and negative 5 plus 4. And that's going to equal negative 5, y, negative 2, negative 1. Now, I've got a 2 by 2 matrix equaling a 2 by 2 matrix. So this has to equal this. Does negative 2 plus negative 3 equal negative 5? Yeah? So far we're true, right? Then I would say this plus this, or that has to equal that. So 1 plus 6 has to equal y. So y has to be 7. Then I would say that has to equal that. So x plus 7 has to equal negative 2. So x has to be negative 9. And lastly, I would say that negative 5 plus 4 has to equal negative 1. And that is also true. So my 2 answers here, what x is and what y is, that's what we were looking for. X equals negative 9 and y equals 7. If that's the case, we have a true statement. there's two different kinds of multiplication in matrices. There's scalar multiplication, which we will deal with today, and there's matrix multiplication, which we'll deal with on Wednesday. Okay? Scalar multiplication is like the distributive property, where you've got a number in front of the matrix, and you simply have to multiply every element of the matrix by that number. It's fast, it's quick, it's easy. Matrix multiplication, preview of Wednesday, a little more involved. Okay? But scalar multiplication is just that. So then this would become negative 3 times 3 is negative 9. Negative 3 times negative 2 is 6. Negative 3 times 1 is negative 3. Negative 3 times negative 10 is positive 30. Adding, subtracting, and scalar multiplication do not change the size of your matrix. With that being said, let's take it to the next level, and let's have you try this one. A combination of scalar multiplication and addition. I would do the distributing for, well, first off, 2 by 2 matrix, that's not going to change size. When I multiply in the 4, minus a 2 by 2 matrix, that's doable. Okay? So I would first multiply this in, and then that's going to give me 8, 12, negative 4, and 20. Then I would subtract off this matrix. So that's going to be 8 minus 6, and 12 minus negative 4, and negative 4 minus 1, and 20 minus 5. And so that is going to give me, I gotta hit it there. That is going to give me 2, 16, negative 5, and 15. So the 2 by 2 matrix, 2, 16, negative 5, 15. Is what I get. Questions, comments, concerns? For that one? See, it's right underneath. Negative 6, 14, 2, negative 4. 2 plus negative 6 is negative 4. Negative 3 plus 14 is 11. 0 plus 2 is 2. 1 plus negative 4 is negative 3. That gives me a 2 by 2 matrix. Negative 4, 11, 2, negative 3. Yes, love it. Oh, yeah. I know, right? Then they take it to the next level, then they take it to the next level, and then they take it to this level. Just just be thankful all of the fractions, or excuse me, all of the elements in the first one are divisible by 4. Negative 3 plus 3 is going to be 0. 0 plus 9 is 9. 6 plus negative 7 is negative 1. And then we got 3/4 y minus 4. And that's going to equal x, 9, negative 1, and 5. So that tells me then that 0 has to equal x. That tells me then that 9 has to equal 9. Tells me that negative 1 has to equal negative 1. And it tells me that 3/4 y minus 4 has to equal 5. That's the case. X is 0. Yep. 9 is 9. Yep. Negative 1 is negative 1. But over here, 3/4 y has to equal 9. And then I would multiply by 4/3. And I get y is 12. Questions, comments, concerns, clarifications? Yes, ma'am.
When we're doing like homework for this test, would you like us to show all of that work?
You wouldn't have to show red or orange.
Okay.
Green and purple, yes. Okay? Because I call the red and the orange one the controls. You know, because, yeah, 9's equal to 9. There's no work to be done there. And there's no point that I need to really show it. But I just write it down. But yeah, otherwise, for sure, all that purple work, yes. Okay. And all the other work above that is kind of what you gotta show, you know, at least to get to there, especially when you're multiplying with a fraction and stuff like that. So, yeah, the more you write down, it really makes it go a lot easier because other than trying to carry too much stuff in your brain and then you get confused, and that's where mistakes happen. So. Formative tomorrow on the MRC. You get a quiz on Friday.